students, I am R Patil. Today we are going to obtain a very important quantity called potential gradient, or the relation between electric field and potential. In the previous classes we have studied electric field and electric potential and potential difference. And according to the definition, electric field at a point in an electric field, intensity of electric field in an electrostatic field is defined as it is the force per unit charge, E equal to F upon Q naught. Consider a positive charge and let A and B be the 2 points in an electrostatic field, and these 2 points are very close so that the electric field between A and B is approximately the same, and let V be the potential at B and V minus dV be the potential at A. As distance increases, potential decreases. Therefore, B is at higher potential and A is at lower potential. And electric field between A and B is force per unit charge, force acting on a charge placed at A and B, that is F upon Q naught. And this implies F equal to Q naught into E. This is the electrostatic force, repulsive force acting on a test charge placed at that point. And the work done to move a charge from A to B is WAB. And we know that work done is equal to force into component of displacement. That is WAB equal to force F into dr cos theta, where dr is the small distance between A and B, and theta is the angle between electric field or electric force and displacement. F and D, the angle between F and D, they are in opposite direction. Therefore, angle between them is 180 degree. If theta equal to 180 degree, then cos theta equal to minus 1. Therefore, WAB is equal to minus F into dr. But we know that F equal to Q naught into E. Substitute this value, therefore minus Q naught into E into dr. Consider this as equation 1. And the potential difference between point B and A. Potential difference is nothing but it is the difference between the potentials at any 2 points in an electric field. Therefore, potential difference between B and A is VBA. VA denotes potential, and VBA, it is the potential difference between A and B and A, and that is equal to VB minus VA, where VB is potential at A and VA is equal to V minus dV. Therefore, VBA equal to V minus of V minus dV. That is the difference between potentials at any 2 points in an electric field, and that is equal to V minus into plus, minus plus V minus V is equal to 0, then minus V into minus V, minus into minus plus dV. Therefore, VBA is equal to dV. It represents potential difference between the points B and A. And also the potential difference between any 2 points in an electric field is defined as it is the work done in moving a charge from one point to another point against the field per unit charge is called potential difference. Thus, potential difference VBA is equal to work done in moving a charge from A to B per unit charge. This implies WAB, work done in moving a charge from A to B, that is WAB is equal to Q naught into VBA. But we know that VBA, that is the potential difference, is equal to dV. Hence, WAB equal to Q naught into dV. And consider this as equation 2. From equation 1 and 2, this is also work done in moving a charge from one point to another point. And equation 2 also gives work done in moving a charge from A to B. And these two are similar. Hence, comparing equations 1 and 2. Equation 1 is minus Q naught E into dr, that is equal to Q naught into dV. Here Q naught and Q naught get cancelled, remaining minus E dr equal to dV. And this can be written as E equal to minus dV upon dr. dV upon dr. Here the quantity dV upon dr represents potential gradient. Potential gradient. And potential gradient is defined as it is the potential difference per unit distance. Potential difference, dV is potential difference per unit distance is called potential gradient. And the unit of potential gradient is potential difference. SI unit of potential difference is volt. Potential is also volt. And unit of dr, that is distance, is meter. Therefore, volt per meter. Volt per meter. And electric field. Here electric field is defined as it is the force per unit charge at a point in an electric field. And here E equal to minus dV upon dr. Here electric field can also be defined as it is the negative potential gradient. Negative potential gradient. And its unit is volt per meter. Volt per meter. And here the SI unit of electric field is Newton per Coulomb. Hence, SI unit of electric field is Newton per Coulomb or volt per meter. An electric field at a point in an electric field is said to be 1 Newton per Coulomb if 1 Newton force acting on unit charge in an electric field, then the intensity of electric field at that point is said to be 1 Newton per Coulomb. And according to this definition, electric field at any point in an electric field is defined as it is the potential difference. If the potential difference between 2 points is 1 volt and the, the distance between the points is 1 meter, then intensity is said to be 1 volt per meter. Or electric intensity is defined as it is the work done between any 2 points separated by 1 meter at a constant potential difference of 1 volt. Then field is said to be 1 volt per meter. Hence, SI unit of electric field is Newton per coulomb or volt per meter. Newton per coulomb or volt per meter. And this relation is very important for 3 marks. That is, obtain the relation between field and potential. And whenever we say field and potential, that is electric field and electric potential. Clear? Then what is potential gradient? Potential gradient is the ratio of potential difference to the distance or displacement. Or potential gradient is defined as it is potential difference per unit length. Potential difference per unit length is called potential gradient, and electric field is equal to negative of potential gradient. Clear? Thank you.